This tutorial is just going through exercise 4D. You should have already watched the video tutorials explaining the theory behind exercise 4D before you watch this tutorial. The exercises here are simply about multiplication, division, addition, subtraction, and the use of de Moivre's theorem regarding polar complex numbers. So here we have a whole series of problems that are looking at the multiplication of complex numbers. I've written them out in detail, so I don't need to spend very much time explaining. Just watch out for the following things. Looking at this one here, it's just two straight complex numbers multiplying each other, and as such, as we can see down here, we multiply the arguments, that was the rule, and multiply the modulus, sorry, that was the rule, and we add together the arguments. Alright, so to make it clear, we're multiplying the modulus, so 4 by 3, and we add together the arguments here to produce this. Now, by the way, I've mostly not used the calculator, although I'll use the calculator towards the end. You should get used to doing both, because you might come across these sorts of things on the first exam and you will not have your calculator with you. So looking at these fractions here, I'm looking for a common denominator. So the common denominator is 12. So what do I do to make this 3 or 12? I multiply it by 4. So I have to multiply that by 4. So it becomes 8 pi over 12. And this one here, I have to multiply both top and bottom by 3. So that becomes 9. So it's 8 plus 9. That's where I get 17 pi on 12. And that really is the answer. However, an argument, of course, is only found between the interval of minus pi and pi. Where does that lie? Well, it doesn't lie in that interval. So we now have to look and change that and find it, the one between that. That is an argument with a small a, but it's not the argument with a capital A. So here we see, just said, well, okay, look, 17 pi over 12 is, in fact, is more than pi by 5 pi over 12. So if we went all the way around there, that would be 17 pi on 12. And you can see we've gone past pi by 5 on 12. We've moved into the third quadrant. So that means we will measure backwards. So the argument is actually found here, is minus 7 pi on 12, that angle. So that then becomes our answer. So while that answer there is just about the end of it, we then have to use proper notation and make sure that we express the argument as the main argument, which is minus 7 pi on 12. And that's so for all of the problems that follow. These types of problems here involve what we've just done here, and also de Moivre's theorem. And here we will recall that to work this part out, we have to multiply the argument by whatever the number here is. So this will be multiplied by minus 6, and we have to put the argument, the modulus, to the power of minus 6. So this one will become a half to the power of minus 6, and this one will become cis minus 6 pi over 8. And then the same thing happens here, and then we multiply them together. So the rules are pretty easy, but it just becomes a bit complex, and there's a bit of algebra involved as well as use of fractions, as well as use of things like remembering, for example, that that to the power of minus 6 is in fact equal to 2 to the power of 6, isn't it? Remember, because something like 2 to the power of minus 3 is equal to 1 over 2 to the power of 3. This has a reciprocal effect. So just remember those things. So there's a few little traps in here, but it basically still comes back to that theory. Moving along, that was a continuation of the first question. What have we done here? It's continuation of the first question, still more of that, still the first question, still no second question here. This one in here, we're just using this. It's only asked you for the argument. For each of the following, find that. It only wants the argument, and also wants that. So looking at this problem here, the argument of this one is pi on 4, the argument of this one is pi on 3, and and notice I've said that here. So multiplying them together is simply a matter of adding these two arguments. So it becomes this plus this to give us our final argument. And once again, I have to go searching. Does that lie within the interval of minus pi and pi. If it does, which it does in this case, we're okay. If not, I have to go and searching for an argument which does in fact fit within that interval. Moving on, question 3 here, similar sorts of problems. I'm not going to explain that. This is actually a proof where I did have to prove that one was equal to the other. It says show that, and so you can follow that through yourself. I've tried to put in every single step using these symmetry properties and so forth, and so on, and continued on the next page. That question goes on and on, doesn't it?